Welcome to HB Tuner's Ford Gen 1 Coyote Training Part 16. In this training module, we're going to take a look at tuning our O2 transport delay. Now, the O2 transport delay is going to factor in how long it takes for the O2 sensor to register a lambda reading after the lambda has been actually changed. So it's going to feed back into the closed loop fuel correction process, and the O2 transport delay has to be right. So it's one of the very first things we need to calibrate and tune. I'm going to be demonstrating how to do that. We're going to look at using an Excel spreadsheet calculator and log data from our histograms to be able to populate out the O2 transport delay values so they're correct for your application. We have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with programming our O2 transport delay within our Ford Gen 1 Coyote applications. Our O2 transport delay table needs to be updated if we've installed a set of long tube headers on our engine. We'll find that the long tube header is going to be spacing the primary oxygen sensor, or the front oxygen sensor that reports back what the lambda mixture is going to be in our exhaust stream. It's going to start to delay and change the way the sensor is going to be registering and feeding back into the ECU. This is especially important that we update this because the Ford Gen 1 Coyotes are full-time closed-loop operation, meaning at idle and part throttle and wide open throttle, it's relying on the lambda sensor measurement from the actual primary front sensors. So we need to go and make sure the O2 transport delay table is nailed down as best as possible. Now, a lot of times if you speak with different Ford tuners, they're going to say just apply a generic correction across the whole table. I found a little bit better method to go about calibrating and tuning this table out that gives me a little bit better control in terms of the closed loop type of feedback in transient and decel type of conditions. So we can apply a generic correction and just correct based on just a percentage of change, or we can get a little bit more specific, and that's what I'm going to show you how to do in this tutorial. Now, if you have stock headers or a shorty style header, you may not have to touch your O2 transport delay table. It's going to be really left up to you if you want to go through the hassle of doing it or not. But with a long tube, we definitely have to go and update some things. So let's go in and talk about where we're going to find the O2 transport delay table and then what we need to do to start to calibrate some things. So let me go here and we're going to jump into a 2013 Mustang GT file. I can save the file here as base cal1. This is just pretty much a stock equivalent file right now. I haven't updated or touched my O2 transport delay table. Now, the vehicle that I'm sitting in has long tube headers. It has a catback exhaust. It does have high flow cats. It has a stock mass airflow housing, stock cold air style intake, and stock injectors. So this will really be easy to see any kind of effect of the O2 transport delay and having to update it with the long tube header in place. We'll find that once you start to add injectors and you change out the intake, sometimes it starts to skew some things. It's a little bit harder to dial in the O2 transport delay. We can usually use the MAF rescaling tool that I provided in the training course. We're going to be taking a look at how to use that and talk about that next in the next actual training tutorial. But we'll find once we get a rough scale on our MAF curve, we can go in and calibrate the O2 transport delay table before we do the actual MAF tuning. We want to make sure that the O2 transport is nailed down as best as possible so we get the best results for the closed loop behavior. So this is going to drive the closed loop behavior and the reporting of the lambda measurement back to the actual ECU so it makes accurate changes in closed loop. If we have bad data in, we'll have bad data out. So we want to make sure that we're providing good data into the PCM whenever possible. So what we're going to do here is jump into our engine area, and then we're going to go in from our engine, and we're going to go in from fuel here, and jump over here into oxygen sensors. This is where we find all kinds of information about our front O2 sensors, even our rear O2 sensor control. Find that in the downstream fore aft oxygen sensor control. We're not going to touch any of that right now. What we're interested is going into transport delay. And if we move down here, we're going to go down into the transport delay table, and there's a transport time constant. Let's look at these two tables. So the transport delay table here is going to represent in seconds, based on engine load and engine speed, what the transport delay needs to be in order to provide accurate readings from our front O2 sensor. So what this is going to do and how this is actually going to work, and you'll find different definitions online, but the actual true definition of this table, it's actually going to be measuring how long it takes from one lambda measurement to the next. So the difference of the actual movement in time of that sensor. So how long it takes to react for a change. So let's say the command at lambda was at 1.0 and the command at lambda goes to 0.9, and how quickly the oxygen sensor actually reacts to that change in our command at fuel or command at lambda that we're programming through our PCM. If we characterize that properly, we'll find that Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.